Assalamualaikum warahmatullahi wabarakatuh and good day. Alright, so this is our second lesson for advanced pharmacology. Last week we have looked into the drug development process. So this week we are going to look at pharmacogenetics and pharmacogenomics. So these two fields are quite new, especially in pharmacology. And there are many researches that are being conducted to investigate this field. So let us go through the lesson to know what does it mean by pharmacogenetics and also pharmacogenomics. All right, a trivia question. Before we start our lesson, let us ask a question for us to think about. Okay, how do we know if a patient will respond or have an adverse response to a drug? Okay, we have heard many cases when a drug is given to a patient, he does not respond to the drug, whereas the same exact drug is also given to other patients for the same disease, for the same pathology. However, the results are different. Have you ever wondered why? And also, we have also heard that someone or a patient is having adverse reaction or adverse side effects because of the drug. And ironically, the same exact drug is also given to other patients, but they have no problems at all. And in addition, it's also working on them. So what makes the difference? Why the effects are different between people? So why does the drug response vary? It's just the same drug, it's the same dose, it's the same routes of administration, it's the same company, it's the same producer, yet the results are different, the response are different. So we can say that the drug itself is a constant variable. So the dependent variable the dependent variable is actually human. Okay, because the humans are different. The drugs are given to different people. So then they must be because of the people. So what causes these differences? All right. So the objectives of this lesson are to define pharmacogenetics and pharmacogenomics and able to distinguish between those two concepts, understanding of our genetic code and its relationship to drug efficacy, and then discuss on how does the concepts applied for personalized medicine. And last one is to discuss several examples of the personalized medicines in selected diseases. All right, as the introduction, so to answer the question that I have posted just now, why the drug response vary between individuals? So there are several factors actually. So I have listed a few factors that contribute to the variation in the response or results in the patients. So the first one is pathogenesis and the severity of the disease being treated. Okay, people do not have the same degree of severity of the disease. And also sometimes the pathogenesis are also different. There are many ways or there are many pathogenesis that can lead to one problem. All right. For example, diabetes. So you have diabetes type 1, diabetes type 2. But in general, you have diabetes mellitus. However, the pathogenesis, the etiology of type 1 and type 2 are different. So that's one example how pathogenesis and the severity of the disease is being treated. And also, in case of diabetes mellitus again, if the person has just got the disease, diabetes mellitus, maybe the person can only use a drug, for example, glycoside, metformin, and so on to control his blood control. However, if the problem has persisted over several years, over tens of years, then the person might need to take insulin to control the blood glucose. So that also determines the variations in the response to the drug. Then drug interactions from concomitant treatments, for example, plasma, protein binding, metabolism. So there are also interference in terms of the concomitant treatments, what kind of drugs have been are being taken by the patients. Okay, there may be drug-drug interaction that will also affect the response and results of the drug itself. And then the third one, individual's age, gender, lifestyle, including environmental factors, behavior, nutritional state, renal and liver function, and concomitant illnesses. So all these factors can actually contribute to the variation in the response of the drug. And the last one is genetic variation. So among individuals, there are genetic variations. Some people carries the same genetic, but it has a modification in terms of its DNA sequence, in terms of its protein sequence or enzyme sequence or receptor sequence. So all these variations actually produce a different results, even though the same drug is being given. A patient's response to a drug may depend on factors that can vary according to the alleles that an individual carries, including pharmacokinetic factors, which you already know, ADME, absorption, distribution, metabolism, and elimination, and also pharmacodynamic factors, the target proteins, downstream messengers. So in pharmacokinetics, you have drug metabolizing enzymes, for example, cytochrome P450 that reside in your liver, and also drug transporter proteins, for example, transporter protein OATP that transports or secretes the metabolites in your liver into the bile. So all the variation in these enzymes, in these proteins, can lead to the variability in drug effectiveness and also safety. And that is under pharmacokinetics. And under pharmacodynamics, the drug target protein. So as a rule of thumb, when you consume drug, and then the drug will go to into your body, will be absorbed, will be distributed, will be metabolized. So this drug will go to the cells of target, okay, the target cells, and then the target cells contain the receptors. So the variation in the sequence of the receptor of the protein will also affect how it responds to the drug. Maybe if there is a variation in the receptor, so the receptor does not bind to the drug. That's why you do not get any positive response towards the drug. And all the variations in these proteins can actually lead to variability in drug effectiveness and safety. So what's the definition of pharmacogenomics and pharmacogenetics? What's the difference between them? Pharmacogenomics are the science of how genes affect the way people respond to drugs. Okay, how genes affect the way people respond to drugs. So how genes affect the way our body processes drugs. This is pharmacokinetics. And then the interaction of drugs with receptors, and this is pharmacodynamics. The treatment efficacy and adverse side effects. And pharmacogenetics is actually a subset of pharmacogenomics. It's actually under pharmacogenomics. It is a study of how inherited variation affects drug response and metabolism. So how does the variation that is inherited from the parents, from the grandparents, and how it affects the drug response and metabolism. So in the event of maybe father and mother experience ineffectiveness of a drug, then the offspring or the child might also inherit the same thing.